Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about the angle-angle similarity theorem for triangles. And so in the past we've looked at triangles, and the way that we have discovered that they are actually similar triangles is by looking at the ratios of their corresponding sides. So here the corresponding sides of this triangle would be AC and DF are corresponding, EF and BC are corresponding, and then AB to DE are corresponding. And the way we would set this up as a set of ratios is we would say 22.5 over 15 equal to 21 over 14 is equal to 15 over 10. Okay, so we have the corresponding parts matching up. The 15 and the 22.5 are corresponding. The 21 and the 14 are corresponding. And then the 15 and the 10 are also corresponding sides. And then what we would do to see if these two triangles are in fact similar triangles, we would check the ratios and to see if they're all congruent. So in this case, 22.5 divided by 15 is 1.5, 21 divided by 14 is 1.5, and 15 divided by 10 is also 1.5. So then when all those values come out to be equal, we can say, yeah, these two triangles are similar triangles. And that is using what we call the side-side-side theorem, which basically says you have to check to see all of the sides are proportional. Now, another way we can look to see if triangles are similar triangles is by the angle-angle similarity theorem, which really is dealing only with the angles. So last time we were dealing with the sides, now we're dealing with the angles. So it says this: if two pairs of corresponding angles in two triangles are congruent, then the two triangles are similar. So let's look at what that means in terms of a diagram here. Here we have triangle ABC, and we have triangle DEF. And let's suppose we knew that angle C was congruent to angle F. And let's say we knew that angle D was congruent to angle A. So by this new theorem, which we call the angle-angle similarity theorem, we could say, since angle C is congruent to angle F and angle D is congruent to angle B, then we could say that in fact these two triangles are similar. And really that's all we're looking for in triangles, is to see if there are two pairs of corresponding or congruent angles. So the green pair, that would be one pair of congruent angles, and the red pair would be another pair of congruent angles. And then of course we know that what follows from that is that yes, in fact, angle E and angle B end up being congruent. And we know that by the triangle sum theorem, which says that all the angles inside of a triangle add up to 180 degrees. So now let's look at an example. And we have these two triangles that are in question, and we want to determine if they are similar triangles. And so first we want to start by maybe just looking at what are the corresponding angles in this diagram. So we have 85 corresponds with this 85. And we know, using the triangle sum theorem, that this is going to be 50 degrees here, and that this is going to be 45 degrees. So then we can say that 45 corresponds with this one, and that angle 50 corresponds with this angle 50. So yes, in fact, these are similar triangles. Now, if I gave you more information about the problem and say, let's say we knew that this was 7, 9, and 6, and then we knew that this is 10.8 here, and 12.6, and then x. Okay, then we could use that information, the fact that these are two similar triangles, to actually solve for the value of x. Whereas before, unless we already knew that these are similar triangles, we wouldn't be able to find x, the side length, which is zy. So we could set up a proportion here. There's several you could use, but I'm going to go ahead and use 7 over 10.8. I'm sorry, not 10.8. 7 over 12.6. So 7 over 12.6 is equal to 9 over x. And again, those are the corresponding parts here. And we see that the 7 represents from green to blue on this triangle, and the 12.6 represents from green to blue on this triangle. And then the 9 represents from blue to red on this triangle, and then the x represents from blue to red on this triangle. So we would use our cross product here. We'd say 9 times 12.6 equals 7x. And then we would solve for x here. And then once we solve for x, we get that x is in fact 16.2. But again, we don't start this problem by setting up the proportions with the sides, because the sides, we can't do that. We can't set up the side proportions until we know that the two triangles are similar. And the way we found out that they were similar was using the angle measures. So let's look at another example here. And in this one, we're going to use our, again, the triangle sum theorem, which says that all three angles in the triangle add up to 180. And here we also know that these are isosceles triangles, which means the base angles are congruent. So that means I can say that this is 71 degrees and this is 38 degrees. And then I can say these two are also 71 degrees. And then again, based on the angles here of these two triangles, we can say they are congruent, or I'm sorry, they are similar. Real quick on this last one, we needed to write the triangle similarity statement. So we could use triangle JLK is similar to triangle. And then here you want to start with the same angle, the corresponding angles, which would be y. So J and Y line up. And then L lines up with X, so we put that next. And then K to Z. Okay. So in this one, we know that the two triangles are also similar. So let's write that as triangle MNO is similar to triangle RQP. And here you could probably switch the P and the Q, since we're not really, we're not going to be real picky about the fact that, yeah, these are two congruent angles. Okay. Now, we can use this now even to solve for more information. So let's say if I gave you that this side length was 36.9 and this was 33, and then I gave you that this was 11 and this was x. Well, we could use a proportion again here to solve for what x is. We could say 36.9 over 33 is equal to x over 11. So you're going to use your cross product again and say 36.9 times 11 equals 33x. And then when we solve for x, we get that x is 12.3. All right, let's look at this example. Here we're given the fact that the the line on the top here and the line on the bottom are parallel lines, which is going to help us to identify which angles are congruent. And so if we look at this diagram as if this was a transversal, one transversal, we can see that this angle and this angle are going to be congruent because they're alternate interior angles. And then similarly, we could say that the other way, as this being the only transversal, we could say that angle is congruent to that angle because of alternate interior angles. And so here we already have a pair of corresponding congruent angles. So the green angles are congruent, the red angles are congruent. Therefore, these two triangles are similar. But you could also even say that this angle is congruent to this angle because of vertical angles. So now we can say triangle ABC is similar to triangle EDC. And then if we wanted to solve for x here, we could set up another proportion where we could say 4 over x is equal to 7 over 5. And use your cross product. You take 4 times 5, which is 20, equals 7x. And then take 20 and divide by 7. So that x is going to be equal to 2.8 approximately. Okay? And the next example, Again, we know that there are parallel lines in this figure, and we're looking at the triangle, the small triangle here, versus the big triangle, which is here. So two very different triangles, and they are inside of each other. But we can say that angle Q and angle R are congruent because of corresponding angles of parallel lines. So there's the parallel lines and the transversal. And then we can also say that angle U and angle T are corresponding angles. They're all congruent because of parallel lines again. And so now we can say that triangle SRT is similar to triangle SQU. So this wraps up our notes for similarity in triangles using the angle-angle similarity theorem. And bring your questions for class on Wednesday. Thank you very much.